or no? I'm Chuck Fleming, K0CHP. I'm going to blow through this as quick as I can. I'm here to talk about test equipment and a couple of particular pieces that we wanted to demonstrate. We'll see if we get to that. I'm a physicist and a test equipment junkie because knowing there's stuff going on around me that I can't detect pisses me off. So I have much more test equipment than any human being should have. So real quickly, just so I know, how many general class licenses you got? Technician class, extras? Okay, good. Tells me where we're going. The big questions, how about our readers, people that operate on batteries? Okay, that also helps me calibrate. One of the big questions we all have as amateurs is all this stuff doing what it says it's doing? Am I actually transmitting anything? And that's actually not always a real simple question to answer. See if we can find the right button here. Okay, that's my test equipment rack in my main bench. So I've got stuff. My initial thoughts on all of this, it's really interesting to talk about tuners and antennas and how we adjust antennas, but one of the realizations that came to me some time ago is that above 100 megahertz, anything over about 50 watts is pointless, unless you're doing Earth, Moon, Earth, or something exotic like that. Because assuming reasonable equipment conditions, line of sight on VHF or UHF will take you 50 miles on 5 watts. So there's really not much point going to higher power. Having said that, antenna is everything. How efficiently you're coupling what little signal you got out into space is much more important than fancy tuners, higher power. You can make up for low power with antennas all day. Again, above 100 megahertz, generally it's much easier. We don't use tuners above 100 megahertz generally. We use them on HF. There's a couple of real simple reasons for that. First of all, the VHF and UHF antennas are short enough, it's easy to trim off a half inch, keep fiddling with them until we get them tuned, so they work pretty well. HF, that's not necessarily the case. Also, there's really only 2 bands we're talking about above 100 megahertz. Not being loose there. But 2 meter and 3/4 meter, and those are sort of inherently interresonant, which makes it easy to make an antenna that covers both of them. HF, there's a dozen bands, and they are not interresonant at all in general. So it's much more important to be able to tune one antenna to work across multiple bands. We talked what Ferrex did about Smith charts today. I learned about Smith charts in the 60s as a physicist and budding radio engineer. And the reason we did that, or developed Smith charts, is fundamentally because we didn't have calculators. They are a paper calculator. That's what they were developed for. So that once I plot stuff on a Smith chart, I can take my ruler and my slide rule and figure out what the opposing impedances I need are. Now that we've got it, if we had had the HP35 when Smith charts were developed in the 50s and 60s, they wouldn't have been developed. Again, power requirements. We talk a lot about how much power on the DC side do I need supplied my transceiver. Rule of thumb, if you haven't thought about it, whatever the output power of your transmitter is, transceiver, divide that by 12 and add a little bit of a fudge factor, about 10%, and that gives you about how many amps you need at 12 volts. The interesting thing about that, I've got 2 50-amp DC power supplies on my bench at home. I don't think I've ever used more than 10 amps out of it, even with my 100-watt rigs. SWR, a very critical point, is that it doesn't have anything to do directly with how much energy I'm putting out into space. What SWR are about is making your transmitter happy. Because if you have high standing waves, that means the voltage, the output of your transmitter can get very high. And the transistors out there, usually they pick the cheapest ones they can use to operate at what they've designed the transmitter to do. If the voltage goes over what the design capabilities of the transistor are, the transistors turn into smoke. And that's really the fundamental reason that SWR is important to us, so we don't have high voltages at the output stage for our transmitters. Resonance makes the receivers happy, on the other hand. We couple more energy from space through all the antennas and cables and other stuff into the receiver. Another name for antenna tuners is W0. I use antenna tuners. I've got lots of antenna tuners, but you need to understand that all they're really doing is making the transmitter happy. And it's no guarantee that you're getting anything out into space. By the way, how many people have got dummy loads? It's one of the best tools you can have. And once you get a little bit of other instrumentation. Can't find the buttons on here. I'm not going to talk about this in any detail. The only reason I put this slide up, I use it in a lot of presentations because I, in fact, did build a one-semester college course around basically this slide in the 70s. The real key point I want to make here is if you haven't internalized, if you're not familiar with the concept of time domain versus frequency domain, that is the first step to instrumentation being useful, is understanding what those two things are. In the time domain is what you see on a oscilloscope. It's voltage versus time. And it's telling you what the instantaneous voltage is at any particular time. Frequency domain is just frequency versus, or power versus frequency, voltage versus frequency. And it's two ways of looking at exactly the same information. The reason I use this slide, this is my favorite little oscilloscope, and I've got, again, more oscilloscopes than any sane human should have. This is a bit scope. It's a little tiny one-board oscilloscope that uses your computer for display. It costs about $150. It combines a really nice 20 megahertz digital oscilloscope, reasonably useful spectrum analyzer, arbitrary waveform generator, and logic signal analyzer, all in one little tiny board I can stick in my shirt pocket. Well, the point of this is to illustrate the difference between time domain, where I'm inputting a square wave into a real simple little low-pass filter, and the output, or the goes out, a technical term, turns into this sawtooth waveform. And this is the spectrum display from that same device, that bit scope. The green is again, that input square wave, and you can see all those frequency components. And anytime you have sharp edges, means you've got lots of high frequency components. The yellow is the frequency spectrum of the sawtooth output, and you can see how it slopes off, and what that simple low-pass filter has done is eliminated all those high-frequency components. So that's a kind of a quick way to start to internalize the difference between time domain and frequency domain. How many software-defined radio owners do we have? Excellent. How many SDR play? Okay. I'm not going to talk about multimeters, except that I measure DC amps all the time, and up until a few years ago, a DC clamp meter was an exotic device. I just got a really cool one on Amazon for $22. So if you've hesitated to pick up, I love clamp meters because I can reach into my battery box and stick it on one lead and see how much current I'm pulling out of my lithium-ion batteries that I've only got 10 amps of charging current on the roof of my RV. So if you haven't looked at clamp meters recently, you're into that sort of thing, DC clamp meters are now available, cheap, and elegant. And yes, I do still have an original Simpson multimeter that I paid $105 for in college. was an entire paycheck when I was managing a Radio Shack. And the damn things are now listed on Amazon for $350. SWR power meters, I'm not even going to ask because we're going to at least one of these. Again, this is my collection from 4 years ago, so there have many been added since then. Ease of use. At this point, how many people have got or used a Nano VNA? Excellent, okay. Those obsoleted these almost completely, right? Many devices, I said, I've got tuners, I like my Kia. It has a little light that says when the tire pressure is low. It knows which tire it is, and it knows what the pressure is, and it won't tell me. I've got a really nice LEG tuner for my IC7000. It has a red LED and a green LED. I don't use it. I use this thing because from MFJ for about the same price, it's got a really nice cross-needle SDR forward power meter, or SWR forward power meter, but it also will tell me what the forward power is digitally to 3 places, what the complex impedance, inductance, and capacitance of the load I've got on it is, tells me what inductance and capacitances it's switching into the circuit, and lets me manually adjust those for the same price as the LDG. My point is, as an instrument, I consider, in this case, a tuner is an instrument, okay? In the case of the LDG, it's a dummy load. This thing, I'm going to pass this around. This is the answer to the question. Let me turn it on first. Am I actually transmitting anything? This is one of the very few pieces of equipment that I will personally recommend buy a specific device that you can turn on. These are about $60 on Amazon. It's a very nice RF signal meter. It's a very nice 2 to 2 gigahertz, or 2 megahertz to 2 gigahertz frequency counter. If you hold it, if it's within 5 yards of your 5-watt HT, it will show you what the signal is. You can walk around an antenna. I use my HF rig outside, my 60-foot tower. That's what I use to map my signal from the tower. I just literally walk around the yard, remote keying the transmitter, and looking at the signal level on that. It's high enough resolution on the RF signal strength that I can use it to map signal strength. It also, for VHF and UHF, and if you happen to be using it on one of the HF frequencies, will show you, decode or count and show you what the CTSS frequency of the transmitter is. So it's a neat little device, again, for about $60. One of the few things that I will, because I don't know of any others like this, I recommend it highly. Again, great answer to the question is my transmitter doing what it says it's doing? Antenna analyzers, I've gone through a lot of these, and I used to love them, but again, they're one of those things that have become hopelessly obsolete in the face of the Nano VNAs. So, Nano VNAs. We're into 4th revision, I believe, of Nano VNAs. I think this is the most current available. It's V2, and they've substantially improved these guys. The V2 has a nice big display, of course, but more importantly for me, it has built-in one-button time-domain reflectometry. I figured out a long time ago that most of the things that break in my system are cables, especially since the cable to my tower runs across one of my backyard areas where my horses like to walk and run. and I have patched that damn cable more times than I want to think about. I started using TDR with Hewlett-Packard back in the 60s, and it's great because using TDR, and I'll again try to get to a quick demo of this, it'll tell me how long with a glance at it, and now with the new analysis they can do on the processors built into the things, it will tell me how long the cable is by putting signal on. It'll also show me where any major disruptions in the impedance of that cable are. And it would, literally, I can take my RG, well, no, it's LMA cable, it's one of the higher quality cables for HF, but I've checked it with the TDR built into this VNA. I can bend that cable at a sharp angle, look at the screen, and I can see that sharp angle on the screen. That's a really useful diagnostic tool. One of my favorite, I sold and supported and trained people on vector network analyzers from Hewlett-Packard back in the 70s and 80s. $40,000 pieces of equipment that we did a 2-week training on. And they were magic, they were wonderful. The first one of these I bought just because I could. Somebody made that at the club meeting. I was looking for nano VNA, so I got excited about it. Walmart.com had them listed for $49. I had to have a VNA I bought from Walmart for $49. Just because. Again, I would love to go through a full demo on this. VNA, if you're not familiar with it, they're wonderful for basic SWR measurements, for basic antenna characterization, basic curve tracing for the frequency response of an antenna system. But for more sophisticated things, for characterizing an amplifier, a filter, cable, loads,
They have cool Smith charts.
absolutely. I wasn't going to go there, but thank you.
Just go show the menu of what gets the logic.
I'm sorry?
The menus are unbelievable.
The Nano VNA, I would characterize the current version of the Nano VNA as being just past ready for prime time. There are still some operational peculiarities, but they're entirely functional. One of the neat things that I've got one on my notebook here, if it's still up. Oops. And again, not at the right angle for me to recognize it, so for it to recognize me, so. There we go. One of the coolest things about the Nano VNA has nothing to do with the Nano VNA. The software available for it is amazing. It is one of the most thoughtfully put together, usable, and thorough software packages for instrumentation I have ever run into. And that's, again, after 20 years with Hewlett-Packard, that's a significant recommendation. Smith chart, I did say something about Smith charts. I'll do it. Literally everything an antenna analyzer does, plus a lot more. Okay, now the prize of the day. How many of you have seen the Mini 1300? He's been around for about a year now. Some amateur radio operator in Europe looked at the Nano VNA and said, God, that's cool. It's a really sophisticated piece of general test equipment. But for me to do the things I want to do as an amateur radio operator, well, a bunch of stuff. So they basically took the Nano VNA, customized it for amateur radio use, built a custom interface for it that this is the next step from the Nano VNA. I'm like, okay. I recommend this thing highly. They're around $200 on Amazon. Does everything Nano VNA does, but makes it really easy to do as an amateur radio operator. Let me see if I can just point out a couple of things. It has, one button. I'd love to go through a full demo of this, but that's an hour presentation in and of itself. We're at 4:30, so I'm not going to do that. I'm just going to recommend it highly. It has things like a built-in frequency sweep for up to 6 bands on display at once. So you can, for all the bands you're concerned about on HF, with about 3 buttons, you can have the ability to do an SWR sweep of all the bands you're interested in and show them to you simultaneously. It has built-in 1-button time domain reflectometry, which for cable testing is absolutely wonderful. As built-in, it does all the gain and loss things that the VNA does. This quartz data, if you pick up random quartz crystals and are trying to figure out what frequency they resonate at, you put a little N adapter on the top of this, plug a crystal into it, push the button, it tells you what its resonant frequency is. If you've got a drawer full of crystals, that's really cool. This button down here says Whisper FT8 JT65. It is a complete Whisper FT8 JT65 transmitter for testing your receiver for those digital modes. That's some amateur radio operator in Europe that did this. That's genius. Okay, so I'm not going to say any more about that. It's got a great frequency counter. It's got a really nice little RF signal generator function. It's just a sweet, sweet device. As I implied or meant to at the beginning, where I think the Nano VNA is just past ready for prime time, this is just a little bit short of ready for prime time. The user interface does have some glitches. There is no computer software available for it, which is a major shortcoming of mine. But as a test equipment junkie, I've only had this for about a week. I'm still figuring it out. I may decide it's got some issues that I'm unhappy enough with to change my mind. At this point, this is my go-to device for now, for the foreseeable future. And I've got it, if anybody would like to play with it a little bit, you're welcome. I'm not going to pass it around. Actually, I guess I could. So, it's a little, one of the not quite ready for prime time things is turning it on. You have to hold the button in for like 30 seconds. So I will pass this around. You're welcome to play with it. Push buttons, can't hurt it. Take a look at it. Okay. I consider software-defined radios as a primary piece of test equipment. Especially with the SDR Play, there is a superb piece of like fourth-party software available for those devices that turns it into a really powerful spectrum analyzer, a DC to daylight, it's 10 kilohertz to 4 gigahertz spectrum analyzer. Again, piece of equipment I sold for Hewlett Packard for $80,000. And I encourage you to buy an SDR Play from the SDR Play people and just support their software development. But just out of curiosity, when I saw this on, I think this one was on AliExpress for 20 bucks. It's an SDR Play clone, plugs directly in, uses all the SDR Uno software, including spectrum analyzer software. And it doesn't have the filtering the SDR Plays do, but the point is you can get into SDR for 20 bucks now. Okay? Again, the SDR Play guys are tremendous supporters of the amateur radio community, and I encourage you to utilize it. I'm sorry?
Is SDR Play the software?
Yeah, the software that's used, the software that SDR Play, the group, the manufacturer supports, builds, is SDR Uno. And it is one of the best SDR receiver software packages I have run into. It's incredibly complete, and incredibly well supported. And if you have a question, an email, I don't remember the guy's name, If you look on YouTube for SDR Play, you're going to see this British guy out in his garden demonstrating the things. And if you send an email to them, he'll respond to you. Okay? I recommend them highly. There's a lot of really neat things going on in software-defined radios. I'm not going to go into that. That's a whole other presentation. But almost any time I'm in my shack or operating in the field, I've got an SDR of some kind running with a little stub antenna, and then my transceiver going separately, usually with software connecting the two so that I can glance at a band like with a pan adapter on the SDR. You know, there's a signal there. I touch it on the touch screen, tunes my transmitter to it, and I'm ready to talk. But then because I keep the antennas carefully decoupled by height and other things, I can tell at a glance, again, am I actually transmitting anything? Is it where I think it is? Is it the kind of signal I expect it to be? So I use it both on transmit and receive. I always have my software-defined radios running while I'm transmitting. Just be very careful if you do that, not to couple too much signal into them because you wouldn't smoke the front end. Okay. If you've used spectrum analyzers for very long, and again, I trained people on them for Hewlett Packard back in the 60s and 70s, at a glance, you can tell what kind of signal it is, a tremendous amount about what's coming out of the air. Go ahead.
You mentioned something about a DC daylight spectrum analyzer. I see you said you're still mentioning.
I'm sorry?
You mentioned a DC to daylight spectrum analyzer. I see you've got SDR plus listed on the slide, but you also mentioned SDR. Which one is the
The SDR Play company, organization, on their website, along with SDR Uno and support for a bunch of the other popular SDR software packages. There's 5 or 6 of them that are really good. They have point to or have actually on their website, a spectrum analyzer program that uses all the SDR Play communications interface. So it works very nicely with these little cheap SDR devices. And it's a spectrum analyzer software. It's a full-featured, and I think that's what it's just listed as spectrum analyzer.
So SDR Play does hardware
Yeah.
and software.
Yeah.
So it's the SDR place. Do you happen to know off the top of your head if that one's the Linux hardware?
Yes. In fact, last I checked, it was available for Mac OS and for Ubuntu Unix. And in fact, the source code's available. I've compiled it to run on Raspberry Pi. So its performance degrades a little bit, but it works. Yeah, being able to run a Raspberry Pi with a $20 dongle as a spectrum analyzer is kind of mind-boggling. Okay. I'm not going to talk about oscilloscopes a lot, other than, again, these are things I have way too many of. This is that bit-scope device I talked about. It's getting along in the tooth now. It's about a 3-year-old product. For $140, something you can slip in your shirt pocket next to the computer. If you don't have an oscilloscope and would like to, that's a great place to start. The software that goes with it is, in my mind, pretty brilliant. Okay, this is just the beginning of my oscilloscope collection, by the way. This was a picture I took on my bench last night.
Does the 1980 still work, Jim?
It absolutely does, and that is in fact, I'm impressed. This was Hewlett Packard's first digital oscilloscope. I won't go into the stories on it. It was an absolute ongoing snowball of a disaster. It was originally designed to be the world's first pocket oscilloscope. And its digitizing part, its A to D, was designed to be the world's first pocket digital oscilloscope in the 1970s, 1980 introduction. Right, Hewlett-Packard engineers, give me 5 more watts, 1 more month, 8 more cubic inches in the case, and I can add this feature. So in 1984, they actually shipped the first one. And it was amazing, except that it still had the A to D from the pocket oscilloscope definition 5 years earlier. Its bandwidth, functional digitizing rate, was 10 mega samples per second. Even in the 80s, that was a disaster. But they didn't tell our field engineers what a problem that was. So they were going out to high-end Bell Labs customers and showing this thing off. And the engineers are pushing the digitizing button to go faster. And on a $20,000 oscilloscope, it did not. We got thrown out of a lot of labs. Anyway. More stories. I wish I had more time for them. They're as much fun as anything else we can do. That's it. Any questions? The bit scope. It's advertised as bit scope. BITSCOPE. There are several versions of it with different features. Again, for just a thing you can slip in your shirt pocket, carry around in your computer case. It's sad that I pretty much always have an oscilloscope with me, and this is usually yes, I'm not recovering. I am, in fact, a test equipment junkie, and I make no apologies for it.